Hey guys, in this video I will show you several examples of graphing points in a 3D coordinate system. So let's begin by actually constructing a coordinate system that is three-dimensional. And of course we are making it on paper, so it's meant to be an illusion. But it's convincing enough, and you've got to know it. So this is what we call the z-axis, straight up. The one over here is the x-axis, positive. The axes I am drawing are all positively labeled, okay? Or positively marked up with numbers. So, and then this one here is the y-axis. So this is a basic three-dimensional coordinate system. When you mark lines on this system to indicate where you are, we can just use little dots like this, whichever one you like. So I will use a spacing of 2 here to indicate 1 so that it's big enough. There you go. Likewise over here, mark it up. Keep the spacing the same so you don't distort anything in terms of distances. Keep the spacing the same. Okay, so these are some sample points along each of the coordinate axes. Okay, each of these is known as a coordinate axis. And each of the planes is a coordinate plane. And now we are going to plot a point. All right, so say you are given the following piece of information. There's a point. Let's make it into a tail. Imagine there's a guy right here at the origin. And this guy wants to get to a location because there's a pot of gold waiting at that location, and he will be able to grab it before somebody else does. So here's the guy at the origin. Okay, and this pot of gold is located at the following point. Now you've got to know where a pot of gold is located, right? Because it's a fortune, so you've got to learn this to get to your pot of gold. And let's say it's located at 2, 4, 6. Okay? So how do we reach this point? Well, you can do it many different ways, but I will do it the following way. This guy over here, he can do the following. He can first run down x to x equals 2. So he can round down to x equals 2 over here. Then he can run over to y equals 4. So I'm going to draw arrows, right, to suggest the motions, right? So first he's going there from the origin over to here. Then he's going to run over to y equals 4. So that is 1, 2, 3, 4. Roughly. Okay, that's y equals 4. So that means this point here could be labeled as 2, 4, 0 so far. But then the pot of gold is at 6, so he's got to climb now. So he's got to get a rope and he's got to climb. And how high does he have to climb? Okay, let's take a look. Well, he's got to climb 6 up. So 1, 2, 3, 4, 5, 6. That's 7 up, 6 up. 1, 2, 3, 4, 5, 6. So roughly he's got to climb up to about that point. And once he reaches that point, he can grab his pot of gold. I don't know, imagine it's Mario Brothers, right? There's a pot of gold in a little pedestal at that point, right? So let's trace over this. This is his next move. There you are. And he stops at that point. He grabs his pot of gold. Or imagine it's Rocky. So he goes from here to here. I'm going to draw him at a couple of points. Then he runs over to here, and then he climbs up here. Man, that's a good workout. And then he reaches the top, throws his arms up into the air, and there he is. Okay? He has landed up at the point P equals 2, 4, 6. And those are, Now, these are the basics of drawing a point in three-dimensional space. You've got to identify the x-coordinate, the y-coordinate, and the z-coordinate, as I have done here. Now, is this the only location he can reach? No, of course. Okay, so we also have positive and negative axes. Now, I don't like to draw too much in one picture because then it obscures what's going on and it gets difficult to read sometimes. I think you can handle it. Okay, this is the negative y-axis. And now I will draw back there the negative x-axis. Okay, so back there is the negative x-axis. Now say the guy, and as before actually, before we do anything else, let's mark some dots to indicate points and keep the spacing consistent so things don't become distorted. Okay, same thing with the negative x over here. You can eyeball it sometimes, but be careful with that. Okay, and now, you know, if this guy fell, that would hurt. Okay. Now say he will once again begin from the origin, and he's got to run over to the point P2, whose coordinates are negative 2, negative 4, 8. So he's got to reach that point beginning from the origin. So what sequence of steps will he take to reach that point? Well, take a look. Step by step. You begin with your x, it's negative 2. That means you've got to trace a line. He's going to go over to negative 2. X equals negative 2 is back there, right? Then it says y is negative 4, so he is going to have to turn and go down to negative 4 along the y. 1, 2, 3, 4, negative. Now here you have to be so careful. Okay, so he's turning and he's roughly going over here, right? That's his negative y motion. Okay? Let's trace over that. That's his next move. And then the question, of course, is what is waiting for him at this new point? We'll find out. And then lastly, he's going to have to turn and climb 8 straight up. So 1, 2, 3, 4, 5, 6, 7, 8. Like that. And there is the point. Okay, that is the point. Once you reach the point, what is waiting for him there? I don't know, you tell me. Okay, send me an email and tell me what is waiting for the guy at this point here. Is it a pot of gold? Is it a, I don't know, girl he's going to marry? I don't know. A princess? I don't know. Or a dragon waiting to eat him? Who knows? Alright. But then I guess he wouldn't be going there unless he's a knight. So, what's important to you is begin from here, the origin, 0, 0, 0. You've got to know that you've got to travel this way along the negative x, turn, travel to negative 4 along the y, and then straight up until you reach the point. And you know what? He decided to change his color, so now he's a blue. There you go. So he's up there, and this is the point you label P2 equals negative 2, negative 4, 8. Okay? That is that point. So these are the basics of plotting points within a 3D coordinate system. Remember, it consists of 3 number lines crossed together. Where they meet, that is known as the origin, because we begin counting from the origin. Any point here, here, or here is counted as positive. That, and of course there's a, I'm going to draw that in by hand. There's a negative x-axis, and I haven't really shown you how to travel down into the pits of, you know, hell and negative z space, but the concept is the same, right? So These are the basics of locating yourself within a 3D coordinate system. And any point in general, therefore, could be described as, or a random point could be described as a pair of x0, y0, and z0. Remember, in mathematics, when you see a subscript of 0, such as this one, this refers to a specific value of x, a specific value of y, a specific value of z. Okay, so for example, 2, 4, 6, or negative 2, negative 4, positive 8. Okay? And now what we can do is the following. What if this guy now, pretend for a second it's two different guys, okay? And now they want to reach each other. How do they do it? Well, you've got to draw a little segment connecting them, right? A bridge, so to speak. And now the question is, how far is it from here to here, along this bridge, so that Bob over here can say hi to Tom? Well, for that we've got the 3D distance formula, and because we have 2 points, let's apply it and let's actually find that distance. Why not? I developed the distance formula in much more detail in another video, but in this one, let's take a look. It's a good place to review. It's always a good time to review everything. So we will find d, the distance, and I'm switching to this now so it fits on the paper, as the following: x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Okay, so this is the basic setup. I hope you can see that. Not very bright, huh? Alright. Let's see, maybe this one will do better. There we go. So D equals, and you've got to, I suggest, be drawing pictures when you do mathematics. It becomes a completely different process of exploration. It's not pushing symbols around a piece of paper, but beginning to truly understand what you're doing. Okay, there we are. This is our 3D distance formula. Now we plug in, right? So that this guy here can walk over to that guy, and he's going to have to walk a length given by this quantity right here. So let's take a look. x2, you've got to identify all the pieces of information, right? So x2, this is like x2, y2, z2 for this point, right? This point is like x1, y1, z1. So we've got x2 minus x1, that's negative 2 minus 2, which is negative 4. And we square this. You add to it y2 minus y1, so that's negative 4 minus 4, that is negative 8 squared. And you add to it z2 minus z1, so 8 minus 6, which is 2, and you square that quantity. At the end, to find d, you take the square root. Okay? So let's continue here. This is 16 plus 64 plus 4. Making good progress. This guy's probably getting a little impatient, right? Because he wants to run over here, knock this guy out, and steal his pot of gold, maybe. Who knows? Okay. Let's take a look. Let's add these. 16 plus 64 plus 4. There you go. Arithmetic, right? Simple things can trip you up, so you've got to always be ready to handle them. 16 plus 64 plus 4 equals 84. So the distance along this line right here, that this guy, for example, will have to cross to reach that guy, is the root of 84. Well, Can we simplify that a little? Sure. 84 is evenly divisible by 2. It's got a 4 at the end, so... And it's also evenly divisible by 4. So let's write this as 4 times 21 under the square root symbol, and now we apply a basic property that says that the root of a product is the product of the roots, so you can break this into the root of 4 times the root of 21. The root of 4, of course, is 2, so all that remains is 2 times the square root of 21. There you go. So this guy over here, he looks more fit anyway, so he probably would like to cross. To cross from this side to that side, he'll have to run a distance of 2 times the root of 21, and if this is in meters, then that would be the number of meters he'd have to cross. Okay? To go from here to there, or maybe kilometers, who knows. But this is all happening in 3-dimensional space, and I hope you can understand how big a role this must play in video games, right? To do video games well, you've got to have a truly solid grasp of 3-dimensional coordinate systems. Anyway, I am Tom. Thank you for watching, and I hope you've enjoyed this little exploration.